Namaskar. I am S.M. Chaudhari, working as Assistant Professor in Department of Electrical Engineering, All India Shri Shivaji Memorial Society's Institute of Information Technology, AISSMS IOIT, Pune. This presentation is about necessity of starter for DC motors. It covers the starting condition of DC motor, the starting current equation of DC motor, then how motor draws high current at start, and to limit the starting current we use starter. So function of starter is included in this presentation. As we know, the voltage distribution equation for a DC shunt motor is given by V supply voltage equal to EB back EMF plus IARA, that is the armature resistance drop taking place in the armature winding. If we rearrange this equation for armature current IA, we get IA equal to V minus EB divided by RA. Now, if we think of starting instant, that means we have just switched on the supply to the motor. So supply voltage is applied to the motor and the motor armature is yet to rotate. It is yet to deliver useful mechanical output. So this is considered as starting instant. Now, as we know, the back EMF in motor depends on speed of motor. So more speed, more back EMF, less speed, less back EMF. At starting instant, the speed of motor is 0. So obviously EB will be 0. Now, putting this value in armature current equation, we can write IA equal to V minus 0 divided by RA. As we know, the motor armature resistance comes under low resistance category. So if we consider a motor in our lab which operates on 230 volt, and let us assume the armature resistance to be 1 ohm, the equation will be 230 minus 0 divided by 1. So it comes out to be 230 by 1 and it is 230 ampere. So at start, the motor will take current of 230 ampere, which is quite high. So the motor in our lab, I have considered a typical case, 3 kilowatt rating, 230 volt, and maximum full load current is 11 ampere, and the rated speed is 1500 ampere, 1500 RPM, sorry. So the current which motor draws is 230 ampere as per the starting current equation. However, the motor rating is 11 ampere only. So what will happen? The motor will be damaged. That high inrush of current may produce considerable mechanical stress on the winding. The winding may be damaged mechanically. At the same time, due to high current, temperature of motor will increase and it will cause I square R loss, which will be resulting into heat, development of tremendous heat, and insulation will be damaged. So we cannot operate the motor directly like this. We need to limit the starting current. So let's use a starting resistance. As we know the equation, IA is equal to V minus EB divided by RA, armature resistance only. So in series with this armature resistance, if I add some extra resistance, that means in denominator part, I will add some extra resistance. The equation will be RA plus this extra resistance known as starting resistance. So V minus EB divided by RA plus extra resistance, we call it as starting resistance. Let's choose its value as 229 ohm. So again, I put values in the equation 230 minus back EMF 0 divided by RA, which is 1 ohm armature winding resistance, and the starting resistance 229 ohm. So now the current is limited to 1 ampere only. So at start the motor will take 1 ampere, it will draw 1 ampere current from supply, which is a safe current because the motor rating is 11 ampere. And as the motor gathers speed, once it takes the current, it will start rotating, delivering useful mechanical output. This back EMF will increase, which was 0 at start. Since the motor has gathered speed, as we know back EMF depends on speed, the back EMF magnitude will be increased, and this current value will be controlled by the back EMF. So with the starting resistance, the motor takes a safe current of 1 ampere and it can operate in good conditions. It will start delivering useful output. Speed will increase, back EMF will increase, and starting current will be controlled by back EMF. So with no starter, the motor will be damaged, and with starter, it will operate in good conditions. It will draw a safe current and the motor can work safely. So starter is nothing but a variable resistance connected in series with armature. Variable means at start this resistance will be at maximum position, and as the motor gathers speed, the resistance will be gradually cut down. This resistance is used just for starting purpose. It is not going to remain permanently in the circuit. So it is just for the sake of starting purpose. And as I told you, this resistance is gradually cut down. It's not only the resistance which is incorporated in starter. We also have some protective devices used in starter, which can protect the motor against overload condition, which can protect the motor when supply voltage fails or supply to the motor is interrupted. So these two additional devices are incorporated in starter. The types of starters used for DC motor. For DC shunt motor, we use 3-point starter and 4-point starter. The starter terminals available will be labeled as LAF, L for line, A for armature, F for field. So L is usually connected to positive of supply. A belongs to armature of motor. So armature A terminal of motor will be connected to this starter A terminal, and field terminal of motor F will be connected to this field terminal of starter. In the similar way for 4-point starter, we have got LAFN. Additional point is N, which is connected to negative of supply. And for DC series motor, we use 2-point starter. Only 2 points are available, line and armature. So this is in brief about the necessity of starter and types of starter used for DC motor. Thank you. For more information, you can log on to www.aissmsiyt.org.